4 minutes on your do now. I'm coming around. When you do your do now, I'm checking that you box in where. Sorry, you box in what you're looking for and you underline where you're looking. I should see those annotations. Boxing in where, underlining what. Mr. Shields, who's the person missing at your table today? Imani, thank you. Thank you for the annotation. Gentlemen, there's one here at level 0. Can you say chair? Box in where you're going to look, underline what you're looking for. Box in where, underline what you're looking for. Other questions specifically. So on your number, where are you going to look for tool? Table 3. Box that in. What are you looking for? So underline what? So that one you underline. Answer? Yeah. Okay. You're doing correct. I say what? Thank you, Jonathan. I'm sorry, Mark. I missed you, by the way. Okay. You have 1 more minute remaining. When the timer goes off, you'll pass all the way to your left. Left person will stack them neatly. Mariana will grab all of them, hand them to me. You have 12 seconds. Make sure that your name is on the paper. Pass them in. 10, 9, 8, 7, 6. The timer went off, so you're at this point circling and moving on. 7, 6, 5, 4, 3, 2, and 1. So there are 2 shout outs I'm going to give to table 6. That's this table over here. Everybody give them 2 snaps after 2, 1, 2. Try that again, 1, 2. Table 6, everybody at that table was annotating correctly. not only that, as we were collecting them, everybody was already ready to go when they collected them. So thank you for understanding the importance of time. I appreciate that. A couple of other shout outs. One snap after I say their group number, table 1 and table 2. So 2 snaps, 1, 2 for both of them. Everybody at their tables for table 1 and table 2 had all of their annotations. And then I have one more shout out to give. That's for Markel, 2 snaps on 2, 1, 2. Markel has just come back and immediately was annotating, answering questions to the best of his ability. So thank you for coming in and starting off strong. All right, if you will, at your desk, there's this turned over piece of paper that's stapled together. Make sure everybody has one of each. We are only on the first page. Please make sure you stay on the first page. Yes, that's your notes to keep. You'll actually be tearing that off at one point and putting that in your binder. We are starting Unit 5. So Unit 5 is over genetics. It's really probably one of the most interesting lessons and the most fun. But the problem is we have a lot of notes, vocabulary stuff, all of that. It's so important that you keep your stuff with you and you pass out the notes for everybody. It's so important. It's so important that you keep these notes in your binder so that you have them to reference the entire unit. Nobody wants to be the person 3 weeks in who can't tell me what a chromosome is or why it's important that we know what it is. What do you need? I don't have it. All right. So starting at our very first part, I want someone to read the objective for me. We'll go with Naeem. Read the objective.
Describe fluid chromosomes, system.
Chromatids.
System chromatids and what was that word?
Homologous.
Homologous
chromosomes. All right, so let's try this again. Everybody say chromosomes.
Chromosomes.
Everybody say chromosomes.
Chromosomes.
Everybody say chromatids.
Chromatids.
Everybody say chromatids.
Chromatids.
Everybody say homologous.
Homologous.
Everybody say homologous.
Homologous.
Great. Moving on. Please make sure that your stuff underneath your backpack is put away. It's not the time for it. Okay. So, don't write any of this down yet. I'll tell you what to write, when to write it. But right now, I just want you focused on listening and reading what's up on the board. So, what are chromosomes? Naeem, you'll actually already read. So, Nyla, you'll read the first one, Markel the second, and Gabby the third. Nice and loud.
DNA is tightly wound around histone protein, creating a bead-like structure called nucleus.
So you have DNA right here. You should see this. You are familiar with the double helix. It's tightly wound around the histones. The histones, you should remember, are the yo-yos that we wind them around. And then those are all tightly packed together to make a nucleosome. Okay, next one. Loud. Louder. And it's a chromatin.
Nucleusum is then packed in the tire and formed into
Chromatin.
let's say formed
Sorry that I took that out. I put into 2. So they're formed into chromatin. Everybody say chromatin.
Chromatin.
Okay, everybody say nucleosome.
Nucleosome.
So the nucleosome are those histones that are packed tightly together. They actually are packed even tighter, and they're turned into chromatin. Okay, a chromatin. Now, chromatin is what makes up a chromosome. So what you're seeing right here, you have your DNA. You have your nucleosome. That's the little things with the yo-yos, the histones. The DNA is wound around it. All of that is even tightly packed into your chromosome. Okay? So what you need to write down in your notes is right here. Go ahead and write this down. I'll read it for you. Chromosomes are made up of tightly wound DNA and protein. Naeem.
I'm not sure what it was. He said my mind is all right at the top.
He is. He's supposed to write at the top where it says, what are chromosomes?
I thought it said bottom line. I thought it was bottom line.
I hear what you're saying. Can you follow directions?
Yeah.
Gotcha. Chromosomes are made up of tightly wound DNA and protein called chromatin. It is where all of your genetic information is contained within the nucleus. Before, when you were picturing those little double helixes in your nucleus, not really, more like chromosomes. I'm going to give you about 30 more seconds to finish it up. All right. Here we go. So, why do chromosomes exist? So these points, I want Shanti to read all of the box, Tiana to read the next 2 lines, and the last 2 lines are Taeyeon. Nice and loud.
DNA has to be replicated when created new
Pause right there. Say it from the very top of this box.
amount of DNA.
There you go.
DNA has to be replicated
You got
when
it.
creating new cells, so it needs to be packed up. I can
Yeah, you got it packed up.
ease of replication.
You got it? Good. Next.
Each truly has 26 chromosomes inherited 23 from each parent.
Great. Last one.
Each cell contains these chromosomes, few expectations,
Exception.
exceptions.
Okay, so in your body, there's like, you have so much DNA that it has to be put into these chromosomes. Otherwise, it wouldn't fit. So, you don't have to write all this down yet. Give me a second, I'll give you the slide. So, the point of this is to say, because there's so much DNA, it needs to be tightly compacted in a way that we can have it all ready to go. Also, that DNA needs to be replicated. If you think about the very beginning of life, right? Very beginning of life, you started out as a unicellular organism. There was one cell that came together. And then you had to divide and divide and divide into a multicellular organism. All of those rounds of division, the DNA has to replicate and then divide out so that each of them have the same amount of DNA. The reason why we have chromosomes is because that makes the process a lot easier. If we didn't have the chromosomes, it would be more challenging to replicate that DNA. The last thing is that we have them because they're given to us by our biological parents. So you have 23 that are inherited from your maternal line or your mother's line, and 23 that are inherited from your paternal line or your father's line. So all of us have those 46. Now, those 46 chromosomes exist in every single cell with a few exceptions. So when we talk about the DNA that exists in your cell and the 46 chromosomes, we're not just talking about one set of 46 somewhere in your body. We're talking about all of them that exist inside the nucleuses. So bottom line, up on the board, write it down. There's so much DNA that it has to be stored in chromosomes. Humans inherit 46 chromosomes, 23 from each parent. And again, biological parent. I'm just gonna like shout everyone out right now as I walk around every one of you. All of you are writing down the information. Thank you so much for committing to that. Is that wrong? No, it said there are 46 total chromosomes, 23 from each parent. You're right. What are you confused about? Okay.
So like, whenever you get, you're 46, right? So whenever you have a kid, is that like 23
It's a good question. Mariana asked a really great question. I'm gonna have her repeat it for everybody. Nice and loud.
So whenever like each
Louder.
parent has 46 chromosomes, so whenever you have a kid that's like 23, you get taken away.
Taken away. So no. So the DNA replication that occurs replicates so that you can have the exact number of chromosomes. That's why DNA replication exists. DNA replication takes the 46 chromosomes that you have and doubles them, right? Makes a copy of them, and then when your cell splits, the next two cells that exist each have 46. So your the cells that are responsible for creating the new human, the sex cells, those cells will have 23 chromosomes that will be donated instead of the normal 46.
So like they give away 23 and then they make more so that's like gene.
They make more, and then once they've made that amount, they give out half. Okay. Great question, by the way, because it leans into what we're doing right now. Track up here. So what do they look like? Sketch both of these. Both of these are one chromosome. Yeah, it looks like a little squiggly line. Yep, sketch it. Make sure that you make these notations. That this little one squiggly line is one chromosome. We also call it one chromatid. This one, this X-looking thing, also one chromosome. But this time it has two chromatids. And once you sketch that, I will explain what that means so that you can focus your attention. I know that you're finished because your pencils are down, your eyes are back up here. Thank you. Thanks, Kathy. Thanks, Jordan. Okay, 10 more seconds. So the question that Mariana asked, I wouldn't necessarily answer right away, but it led really nicely into this next piece. Both of these are one chromosome. This, for example, would be the chromosome that you inherited from your mother or from your maternal line. Okay? That's what this guy represents. This guy is the exact same chromosome that you inherited from your maternal line. However, he has an exact copy attached to him. So this is after, hold on, oh, I love it. I love immediately like the questioning and the curiosity, but listen. This is after DNA replication. So these could represent the same, exact same genetic information. This is pre-DNA replication. This is after DNA replication. So it contains the exact same genetic material. This guy's just a copy. But these are both still only from your maternal line. Name.
And so you need 23 of those, right?
Correct. This is one, this is one. You need 23 from each parent, 46 total. Mark how. Go ahead. Stay on.
So it don't matter how many like chromosomes are combined, it's still gonna be one.
You'll only ever see this one because of it's replicating for the process of cell division.
All right, so it can only be like 2 chromatids combined.
Correct. You'll only see 2 chromatids for one chromosome. I love that analysis. I'm going to take one more question, then we got to move on. Shanti. I only made enough.